Welcome back, kids, as we continue on our second day of studying solids, liquids, and gas. Going to run through our Nearpod slides. Remember, you have access to these slides in our Google Classroom. I can kind of pull that up really quickly. Maybe if I get a shot here, pull that up. And we go under classwork and states of matter. And you can see down here you have your Nearpod codes. You can get into this anytime if you need to go through and pause it. Or you can just watch this video and pause it when you need to. It's up to you. We have solids, liquids, and gas. Very quick review from yesterday. Matter is anything that has mass and takes up space. And we realized that all three, solids, liquids, and gas, are all matter because they do have mass. They do take up space. It just changes with each different state of matter as to how they take up space. Volume is the amount of space an object takes up. And we realized yesterday that some things have a definite volume. They take up a very specific amount of space. And some things do not have a definite volume because they don't take up a specific amount of space because that changes with the environment that they might be in or the pressures being put on them. Shape. Some things have a very specific shape. Some things take the shape of their container, and some things it's really hard to even give them a shape at all because, number one, you can't see a gas. So we'll move on from that. There are three states of matter for now: solids, liquids, and gas. We're not going to get into plasmas. You'll get into that later on. I don't know when they teach that, if it's middle or high school. I need to look, I guess, through the standard course of study to figure that out, but not in 5th grade. Solids are a form of matter that have a definite shape but take up a definite amount of space. And when we're thinking of solids, probably one of the biggest examples we need to think of is an ice, or like an ice cube or ice. Ice is the solid form of water, and it's important to know that state of matter. Now, when it is ice, you need to understand that it is actually still water. It's just water in a frozen state, in a solid state. Water in a solid state. If you were to look at the molecules, it would look exactly like a regular water molecule, except they would be a whole lot closer together than they are in the liquid or in the gas form. Liquids. That is a form of matter that takes up a definite amount of space but has no definite shape. It takes the shape of its container. And we're looking at liquid water here being poured into a glass. Whatever container it was in, the water had the shape of that. Now it's going to take the shape of this glass. If we spill it onto the floor, we remember that it takes the shape of the floor. It kind of comes flat and spread out all over the place. And the important thing to know about liquid is, although it takes up a definite amount of space, it has a definite volume, it does not have a definite shape because it takes the shape of its container. If we were able to look at the molecules of a liquid, they're a little further apart than they are in a solid, and they're not nearly as far apart as they are in a gas. Gases is the third form that we're going to look at, the third state of matter for water. It's still water molecules. If we were to look at them under a microscope, we would be able to see that the water molecules look exactly the same in gas form as they do in liquid and solid form, except they're way further apart. They're moving around with a lot more energy. They do not take up a definite amount of space, and they do not have a definite shape. So no definite volume, no definite shape, but it's still water molecules, and we call that water vapor when water turns into a gas. And we talked about that a little bit yesterday, and we looked a little closer at what the molecules look like. So as we move forward into today, again, we're going to talk a little bit more about what the molecules look like and get into a few more words about how things can change from state to state, which is kind of fun. You need to be watching these videos at home if you have not. Obviously, I can't play a video on here and record it when it's already a recorded video on YouTube. That's a copyright violation. So those of you at home that are watching this need to go back in the Nearpod and watch these videos on your own. If you click on this to sign in, like down here, you'll have to sign into Discovery Education. Hopefully you've done that already this year. You realize it just takes one time to sign in. Then once you sign in, you can just watch all the videos as you move along. Pretty easy to do. Solid, liquid, and gas there. I would like for you to take this 6-question quiz. As you look over here, I would say the class average is like roughly an 80. 78 is close enough to an 80. So if you're not scoring at about an 80% or higher, we need to look at why and go back and maybe change some of our study habits and dig a little bit deeper into those vocabulary words for this week and continue to study those. Go back and look at our notes and study those notes a little bit more. And if that's not working out, I do have another thing that I could try out for you. It's a website or an app called Knowt, Knowt. It takes your notes and turns them into quizzes. But that's something that we would really have to get into if we were like super struggling with things, and we can talk about that later on. Again, like the changes in states of matter. Water can change from state to state. It can go from a solid to a liquid. It can go from a solid to a gas, believe it or not, without ever changing into a liquid. Liquids can go to solids. Liquids can go to gas. Gas can go to liquid, or gas can go to solid. So it can change and bounce back and forth between these three states. And we need to understand how that happens. And I think having a basic understanding of what the molecules look like gives us an idea of when something would do that and what it would look like molecularly when it does do that, which is important. That's why we talk about the molecules. Before we dig into how it can change, we got to look at those molecules again really quickly in this video. You can see here in a solid, and we drew this yesterday. I hope you drew this along with me as if you watched the video. If not, you can do it today. In a solid, the molecules are very, very tightly packed. Now, you see these little lines? That's actually showing that there is a very, very slight amount of movement. We can get into why that does that later on, and how much movement. So, yes, even the pen or pencil that you're holding right now, if you could look at it very, very closely under like a microscope, like a super powerful microscope, molecularly, you would notice that there is like amounts of movement. Are they great amounts of movement? Probably not. And it's going to be really just imperceivable when you're holding the pencil. You don't feel the pencil moving or vibrating or anything. It's at the molecular level that that's happening. Liquids, as you can see here, look at the difference in how the molecules and solids are super close together and touching. Liquids, they're super close and bumping and they're flowing across each other, but they are not as close as they are in a solid. Now, I envision, and I think this helps a lot of kids, and I hate these haven't been around for a long time, but I envision if I could shrink myself down into water and see the molecules, it would be the same thing as me looking at like a glass of Orbeez. Like that's what the molecule, they're touching, they're together, they're moving, and I can move my hand through Orbeez pretty similar to the way I can move it through water. And that's what it looks like when you're moving through water at the molecular level. You're bumping into those molecules, but there's enough space in between them to slide and move and be fluid as they move around, because it's a liquid. Obviously, the next one is gas. And if you look at the molecules in a gas, they're a lot farther apart than they are in both solids and in liquids. And we're able to move a little bit more freely through gas, although you can still feel contact and friction with those molecules in the air when you wave your hand, stick your hand out of a car. And we even see that when things are re-entering the Earth's atmosphere, because if they're moving fast enough, they're hitting those molecules. And a lot of things like meteorites and stuff burn up in the atmosphere because they're hitting molecules of gas in the air. You can watch this one on your own. It's a really good video from Bill Nye. You need to watch this one on your own at home as well. Sorry about that. Now for today, we're going to talk about 3 ways that the states of matter might change. And the first one is the melting point. Now listen, I know if you're like looking at this, you're thinking, oh my goodness, that is like an extremely long, difficult definition. I know that writing down notes sometimes you're just writing what the teacher puts on the board. But if you can put those things into your own words, you probably have a little bit better of an understanding. I'll give you an example. So if I were taking notes on, oh my goodness, what is this, like font 75 or something? Melting point. Okay, so if I'm taking notes on melting point, and if I go back and look at that chart here really quickly, a particular temperature which a substance changes from solid to liquid, every solid has its own different melting point. Okay, how can I take that and break it down into its basics? Okay, so it's the temperature, I'm abbreviating, when a solid turns to a liquid. Okay, done. Melting point, when a solid turns to a liquid. The temperature when a solid turns to a liquid. So an ice cube has a melting point. A bar of gold has a melting point. A bar of lead has a melting point. Different substances that are solids have a melting point that they would reach. And we can talk about that. I mean, if you're talking about like rocks and lava, like they have a melting point from when they turn from a solid into a liquid. So that's something important. So again, when you're taking notes, you don't have to write down everything I have over here. You want to try to put that into your own words and make it as short and simple. If you can explain it, you understand it. If you just are spouting off like an exact definition of something, you probably don't understand the vocabulary word. And the goal is for you to not just learn a a vocabulary definition to spit it back out on a quiz, I need you to understand it. And there's a big difference in learning it for the quiz and forgetting it and actually having deep understanding of something. And so that's something I need for us to work on as we move through this. So melting point is one of the first words we'll talk about. Boiling point. Okay, when liquid becomes a gas, it's called boiling point, or vaporization, or evaporation. Have we heard some of these words before? Vaporization, evaporation, yes. Well, what happens in evaporation? That's when liquid water turns into a gas. So again, if I was going to take some notes on the boiling point, okay, my goodness gracious. So that's the temperature. When a liquid becomes a gas. The temperature when a liquid becomes a gas. Boiling point. Now, boiling point is also very similar to evaporation, isn't it? Because that, if we have a puddle of water outside, we're not going to say the water boiled. No, we would say the water evaporated. So we need to use the correct term in the correct context. But boiling point and evaporation are very similar. That is the point when a liquid turns from a liquid to a gas. So again, you don't have to write everything down here. You really just want to break down boiling point into something that you understand. Okay, if you're thinking about a pot of water on the stove, you're not going to say, well, when that liquid becomes a gas, it's called the boiling point. And you're going to say, hey, when that gets hot enough, it's going to change from liquid to gas. Break it down, make it the words that you would use so that you understand the term a little better. Well, if we have had melting point, if I've had boiling, well, there's only one other thing for right now that we can do to water in its different states that might be a little bit different. And let's talk about that. Freezing point. Freezing point. And I'm not gonna, this is it right here. Look, the temperature when a liquid becomes a solid. Now this one, yeah, you can copy that down because it's not nearly as intricate as the others were. Freezing point. When a liquid becomes a solid, when water becomes ice, is the freezing point. So we've studied 3 different things here. Now we have a lot of things that we're going to talk about with the states of matter. And tomorrow we're going to break them down into, well, maybe I'll do the triangle. We'll see. I might do it a little bit different tomorrow. We got to talk about all the different ways that water can change from state to state, and that's very important. But we'll get that done as time goes by. So freezing point, when a liquid becomes a solid. Now in class today, we practiced some things, so I'm going to go through here and put this into our Google, maybe. There we go. My library. I'm going to click on this. I'm going to assign it as homework. Why am I doing that? Well, we just need to have some people practice this because share link, copy the link. I'm going to go to my Google Classroom, and I'm going to add that into here because just looking at class, I think we still need to practice these motion graphs a little bit more. As you go through this, I would caution you, number 1, make sure you check out what type of graph it is before you try to answer the questions. Number 2, when you are answering the questions, you need to make sure that you are actually reading the graph beforehand. So let's go under here. Let's go view motion graphs, and we'll just put that link in there. There we go. And states of matter notes. And we'll be done with that. That way people can go back in and knock out that quiz if they need to. All right, kiddos. I'm going to leave it at that because we're probably running pretty close to on our time here. Looks like we are. And I will pick back up tomorrow when we go over all the different changes. And then we're going to start talking about chemical and physical changes here really, really soon. Although all the changes that we've been doing to water at this point, we will find out pretty quickly, are just physical changes. Because in the end, it's still water, whether it's ice, whether it's gas, or whether it's in its liquid form. If you have any questions, hit me up on the Google Classroom. And as always, keep on sciencing, and I will see you later.